Hello, I will be telling you guys about Lambda expressions and anonymous objects. So let's start. F11, there we go. So why learn Lambda expressions? So they are a core part of Java, Python, and I'm sure many other programming languages. It's a way of temporarily making functions and or replicating them and then quickly throwing them away into what's called garbage collection, or when the memory space is allocated in the RAM, it is thrown out so that the operating system can use that memory. So you use a lambda expression to temporarily allocate a small amount of space for reusable code or a function. So the deeper you get into programming, the more you'll use lambda expressions, and you'll use it for flexibility and replicating code, assigning functions in lists. So like if you wanted to create an object that had a function, but you wanted to replicate the function within the object over and over again, that's what you'd use lambda expressions for, and with different types of variables. I've seen that happen with tkinter when you try to use a loop to make buttons. And buttons is a part of tkinter. We don't have to go into that, right? But you use a lambda expression in order to create the button action. And the same thing happens in Java as it happens in Python. You use lambda expressions for things like that. I'm sure you also use it for machine learning as well. So first thing to know is that functions can have a reference or a variable that points to it. So generally speaking, we have memory allocated for whatever value, and we have a name or a variable that points to it. So we'll take a look at this. First of all, let's create some code that will be reusable, defining a function func, and it returns yo-yo. Okay. Then we can say there is a reference or pointer called func that points to this function, and it points to return yo-yo. And as you can see, when we run this func, it is shown right here that in the main area we have a function that exists that points to return yo-yo. So we can also run it. We all know this part, hopefully, where you just put the parentheses and it runs it and it returns yo-yo. So in Python, remember, we don't have to push print in Jupyter Notebook in order for yo-yo to appear at the very end of a cell. But if it's at the beginning or the middle, it's not going to show yo-yo. It's going to just disappear. So to do the same thing in the middle of code, you have to put print yo-yo instead of return yo-yo. But I use return for a special reason. I will show you. So I'm going to talk about lambda basics. Let's see. So you see where it says lambda colon yo-yo. So lambda is a keyword that says anything afterwards is going to be special. So you have the colon and you have yo-yo. We've created a function space, I would say. So it allocates space for a function but does nothing and has nothing pointing to it. Anything past this colon is going to be returned. So it would be the same thing as going to this define function return yo-yo, but taking off this define. Instead, you just have return yo-yo. And because you don't have anything pointing to it, it's not usable, and it's what's called anonymous. Anonymous meaning nothing is pointing to me, therefore I will disappear after this moment. Alright, so we can take this anonymous code, right, anonymous function, and call it lam func. And we say lam func is equal to lambda yo-yo. And just remember, I think I said this before, that anything past this colon, there's going to be a return right before yo-yo, and that's just something that's inherent. So now with lam func, we have the same thing as define func return yo-yo, except with a lam right here. So it'd be like that, lam func. It's the same thing except using a lambda expression. So now we have a pointer. So we've made an anonymous function non-anonymous by creating a pointer slash reference. There you go. Lamfunc, so now we can tell that RAM memory space was allocated. So if we were to say, oh, we have to run it. I was like, oh no. Yeah, so we have to run it and then run it, and there it is. Now we have a function that points to this lambda here. And we can run it by simply doing the parentheses, just like before. So here we go. Yo-yo. And it's exactly the same as this define func return yo-yo. So take a look at it. You know, there it is. So you pointed the anonymous function to a variable. You have the RAM space allocated, and you can run it now. Okay, arguments and execution. So you could put arguments into a lambda, and what an argument is, you know how you have the function name and then you have the parentheses. Whatever you put in the parentheses is the argument. So when you do lambda, you can put an argument into it. So take a look. We have this anonymous function lambda, and anything but between the lambda keyword and this colon is going to be arguments. So that means you could put an argument with nothing in it, right? From here to here. I hope I could control Z. So you see that? That right there is an argument that you're going to have to put in the pointer. So you'd put something like myfunc parentheses text, and then it's going to print text. But if you want a default one, just like you would in any function, if you study functions, I can make a video on that, I guess, but args is equal to happy duck. Now you have happy duck as a default. So when you run it, let's see, it's already running. When you run it, it will say happy duck, right? Let's run it. Bam, happy duck. So let's say you want to run it with a different argument. So let's do something else. Let's say my function is equal to this, right? And we run that. And next, let's say my func, and let's put something like I like cheese with my crackers. And we run that, and now it says I like cheese with my crackers. Why? Because we put an argument here that goes to this args, and it replaces happy duck, and then it prints I like cheese with my crackers. And to prove it, watch this. X equal to 1 X. See? So print generally doesn't have this. See, it's just right there, printed, and then 1. That's proof. So let's say you wanted to run it. That's how to put arguments. Let's say you wanted to run it while remaining anonymous, whatever. So then you would put parentheses around the lambda function, and you can see now that it's sort of like encasing it as a function, right? As like a variable, and then you just put the parentheses at the end, and it runs just like myfunc with the parentheses. So, bam, happy duck. All right. So now that you understand how Lambda works, you can combine it with other types of functions and keywords. There's 2 of them that are also core features of Python called maps and filters. Once you learn those, you'll be able to put Lambda expressions in them and create all sorts of fun stuff. Just remember, maps is for reusing Lambda functions over like a list, or what's called an iterable, and you can learn that later. Or you could use a filter, which is when you take a Lambda that returns a Boolean and you try to make an iterable against that Boolean, and it filters out whatever's in the iterable. So if you say Lambda find even, and then you put an iterable that is like 1, 2, 3, and then you put it in filter, it's going to come out with 2. So those are core features, and it's used in many libraries. And just for fun, I'm going to show you guys something pretty cool. So Lambda, oh, it's right there. Okay, take a look at this. You see how it says print args? It could be any function. So let's say we're going to do 2, 5, 6, 7, and maybe 1. And we're going to take another function, min, take a look, 1. So you could put any function in here, not just min. You could make a function like custom function, put any argument and put it in there, and you could just make any function. It's so cool, so flexible. So yeah, that is Lambda functions, and I hope you learned something. Let's see how to exit, and then